In this question, a ship is steering 37 degrees at 10 knots. The question also tells you the water current is setting 257 degrees at 3 knots. We want to find the speed of the ship and the course made good. This is a question pertaining to how to find the resultant velocity vector. From what we have learned in physics, we understand that the actual velocity vector of the ship is actually equal to the velocity vector of the ship itself without any water current plus the velocity vector of the water current. And note that this is a vector addition, so we cannot simply add 10 with 3 directly. So to find out what the actual velocity vector for the ship, we have to draw the vector diagram. Let's assume this ship is starting from this point A over here, and the direction of the ship is 37 degrees from the north. So let me draw the north directions at point A. 37 degrees is roughly this much, so this is 37 degrees. So this vector AB is actually the velocity vector for the ship itself. The magnitude of this velocity vector is 10 knots, given by the question. The question also tells you the water current is 257 degrees from the north. Using the head to tail method that we have learned in physics, we can draw the velocity vector for the water current. So this is the north direction at point B, and the velocity vector for water current is 257 degrees from the north. So let's assume that this is the water current's velocity vector, BC, and the angle here is 257 degrees. The magnitude of velocity vector for the water current, I call it VC, is equal to 3 knots. At this point A is the starting point of this vector diagram. This point C is the ending point of this vector diagram. So eventually, a vector from point A to point C, this vector AC, is actually the actual velocity of the ship, as vector AC is the resultant vector in this vector diagram. In other words, we need to find the direction of this velocity vector as well as its magnitude. That's how we obtained this velocity vector diagram. The question tells you this angle is 37 degrees. So if you look at this north direction and this north direction, they are parallel with each other. So that means to say this is 37, and this angle, as its alternate angle, it should be also equal to 37 degrees. The question also tells you that this big angle here is 257 degrees. So that means to say it will be easy for you to determine this angle B first. So clearly, this angle B is equal to 257 degrees minus of 180 and minus of 37. So this will be 40 degrees. This angle here, 40 degrees. So at this juncture, we already know the length of AB over here, that is 10. We also know the length of BC, that is 3. And we also know the angle included is 40 degrees. So how are we going to find the length of AC? What's the best way? Should it be sine rule or cosine rule?
We should simply use the cosine rule to find the length of AC. So the cosine rule equation goes this way. AC squared, that will be equal to AB squared plus BC squared minus of 2AB AC times the cosine of the angle included, that is 40 degrees. We can then simply plug in the values. AB is 3, BC will be 10, this is 3, this is 10. So you can press a calculator, you can find AC directly. Do not forget to take the square root. The answer for AC will be 7.94 knots. So we have found the magnitude of the ship's velocity already. The second question is, how about its direction? Let's come back to our diagram here. The bearing of the resultant velocity vector is simply this angle down here. So how are we going to find this angle? Clearly, you're going to find the angle A first. If you know this angle A, we can use 37 degrees minus of this blue color angle A, then you have the bearing of the resultant velocity vector. So now our aim is clear. To find angle A, I think the most direct way is to use the sine rule. So we have sine of A divided by the side opposite to A, that is BC, which is 3. That will be equal to the sine of the angle 40 degrees divided by the side that is opposite to 40 degrees, which is AC. How long is that? 7.94. So you can press a calculator and use the sine inverse, we can find the angle A. The angle A here is roughly 14.06 degrees. Therefore, the actual angle of the ship, the course made good, this is equal to 37 degrees minus of 14.06 degrees, which is approximately 23 degrees. We can say it is 023 degrees of bearing.